In today's lesson, we are going to talk about how to solve systems of inequalities. So first of all, before we begin with system of inequality, and when we work with systems of inequalities or just inequalities in general, graphically we'll need to shade. So before we begin, whenever you see an inequality with a less than or a greater than, then graphing them, we will do so using a dotted line. Okay. Whenever you see a less than or equal to or greater than or equal to, then we graph them using a solid line. Okay, so keep those two things in mind before we begin. Alright, so let's take a look at our first problem, which is to graph the inequality y bigger than x plus 1. To graph the inequality y bigger than x plus 1, the first thing we notice is that it's in slope-intercept form already. So the slope is equal to 1, right? And the y-intercept is 1. So the next step is to construct an xy plane, which would look something like this. Okay, xy plane, and we're going to go ahead and plot the y-intercept. So this is the y-axis, okay, the y-axis, the x-axis. The y-intercept is 1, means that you plot -1. I'm sorry, you plot 1. Your slope, it is best to write your slope as a fraction. So the slope is going to be written as 1 over 1. So to plot this line, what we're going to do is we're going to start the y-intercept, and then we're going to rise 1 unit and then run 1 unit. Okay, so from here I'm going to rise 1 and run to the right 1 unit. The reason why I run to the right is because that number is a positive number. Okay, so construct a dotted line through these 2 points. Now the reason why I use a dotted line is because my inequality is a less than, so I use a dotted line. The reason why my slope is 1 is because the slope is the value in front of the letter x, so that value is 1, so the slope is 1, and the y-intercept is this number. If you match it up with y mx plus b, then that's the m value and that's the b value. Okay, so guess what? You have graphed your inequality, and now the next thing to do is to shade the inequality to indicate where the solution set lies. To determine where to shade, the next step is to pick a test point. So part B, pick a test point. Okay, pick a test point. Now you can pick any point you like, as long as it is not on the dotted line. The best test point to pick would be 0, 0. So my test point is going to be 0, 0. Once I have chosen a test point, I'm going to go ahead and plug that test point into the original equation to see whether it's true or false. Okay, but once I plug that in there, I get 0 for y is bigger than 0 plus 1. So 0 is bigger than 1. This is a false statement, okay, because 0 is not bigger than 1. Listen, my test point is in this region. It produces a false statement, which means that the region above the line is the solution. Or in other words, the region above the line will satisfy my inequalities. Okay? So in other words, if your test point produces a false statement, then you shade on the other side of the line. If your test point produces a true statement, then you would shade on that side of the line. Alright, and that's how you would graph an inequality. So the shaded area is the solution. Any point that you pick above the line, which is in the shaded area, will be a solution to that inequality. Let's take a look at another example of inequality before we get to systems of inequality. Okay, second problem. Graph 3x plus 2y plus 4 bigger than or equal to 0. Okay. The first thing we do before we can graph this is to solve for y. So first thing, solve for y. Okay. To solve for y, we subtract 3x and 4 to both sides. And if you subtract 3x and 4 to both sides, then here's what you get. We subtract the 3x and 4 to both sides. Divide both sides by 2. When we divide both sides by 2, we're going to get y is bigger than or equal to negative 3 over 2x minus, divide that by 2 as well, gives you 2. Okay, so it's in slope-intercept form. Notice that our slope is negative 3 over 2. Our y-intercept is negative 2. Now we can go ahead and graph those lines. Graph the line. So I'm going to go ahead and construct my graph over here so that we can do our test point over here. So let's go ahead and construct my graph. Okay. So my slope, my y-intercept is negative 2. So I start at negative 2, negative 1, negative 2. My slope is 3 over 2, so rise over run. Since 3 is a negative number, we're going to rise down. So rising down 3 units from here. So 1, 2, and 3. So let me extend this line a little bit more. So 1, 2, 3. So rising down 3 units and then running 2 units to the right. Okay, and that's my point. So 3 down, 2 to the right, because negative 3, 2. I'm going to go ahead and connect these 2 points with a solid line because my inequality is less than, my inequality is greater than or equal to. So that's why I'm using a solid line, as you can see. Okay, now the next thing I do is I'm going to go ahead and pick a test point to determine where to shade. Okay, so test point. Remember that your test point could be any point as long as it is not on the line, but you want to pick the easiest point to test. And so in this case, I'm going to pick once again 0, 0 again, because that's the easiest point to test. So 0, 0. Replace the test point into the equation, or you can replace it into your original inequality if you like, or you can replace it into this inequality. It's up to you. So I'll use this inequality, plug it in. 0 bigger than negative 3 over 2. 0 minus 2. So that will become 0. So our inequality becomes 0 is greater than or equal to negative 2. 0 greater than or equal to 2. 0 greater than or equal to negative 2 is a true statement. This is true. So because that point produces a solution, because it makes our statement true, therefore every point on this side of the line is also a solution. Okay, so again, the statement is true over here, so we shade on that side of the line. Notice that there's a relation here. Whenever you solve for y and you're dealing with a greater than or equal to, then you always shade above the line. And say if that was a less than or equal to, then I would have shaded below the line. Alright, so that's a shortcut if you if you didn't want to pick a test point. But that's only true once you have solved for y. Let's go ahead and look at a system of inequalities. Okay, so number 3. Okay, graph. Okay, so here's a system of inequality. The first inequality is x plus y less than or equal to 3. Second, y is greater than 1 over 2x. Alright. First thing I'm going to do is I'm going to solve for y in each equation so that I can easily graph the inequality. To solve for y in the first equation, subtract x to both sides. So the first equation is basically y is less than or equal to negative x plus 3. Make sure you know how I went from here to there. Okay, subtract x to both sides. This equation is already in somewhat of slope-intercept form, so all you have to do is carry that over like this. Okay, we're going to go ahead and graph, and then we're going to shade. Okay, so construct my graph, which is over here. Let's do it over here. Okay. This is my graph. First thing I'm going to do is I'm going to graph the first equation using blue marker. Okay, so let me put a wave under the first inequality. So 3. The y-intercept is 3. So 1, 2, 3. Okay. Slope is negative 1 over 1. Very important. Think of a slope. Think of the slope as a fraction. So negative 1 over 1. So negative 1 means you rise down 1. Over 1 means you run 1. And that those 2 points, when I connect them, they are the first line. Okay, so it's like this. Alright. Now, if you recall about my shortcut or the shortcut, whenever we see a less than, we shade below the line. Okay, so the shading is going to be right below this blue line. Okay. Now I'm going to graph this other inequality with a black pen or black marker. Okay. Notice that there is no y-intercept, which means that the y-intercept is 0. Okay. The slope is 1 over 2. So starting here, I'm going to rise 1 and then run 2. So 1, 2. Okay, and that's my other point. I'm going to go ahead and connect these 2 points with a dotted line because it's a less than, I'm sorry, it's a greater than. There's no equal to. So it gets connected with a dotted line. Now, I'm going to shade above this dotted line because I'm looking at a greater than sign. Okay, so here's my shading. Anything that satisfies the inequality, the second inequality here, will have to be above the dotted line, which are here. All right. So again, you don't have to pick a test point. You can just kind of look at each one of these equations and determine which side to shade. This is only true once you have solved for y. Alright? Now, the solution to the system is where the 2 shaded area intersect. So if you look carefully, the 2 shaded area intersected in this region right here. So one way to indicate that is to kind of darken the region to know that that is where I want, that is the solution to my system. Okay, and then you can just kind of erase the other to indicate that none of those areas is the solution. Okay, so my solution lies there. If you don't want to erase the other non-overlapping region, just make sure that you darken this area to indicate to your teacher that that is the solution. Alright, and that should be good. So if you're given a system of 3 equations, then again graph 3 lines and look for the shaded area where the 3 graphs overlap. I will see you in my next video.